Section 2.8, Graphing Linear Inequalities in Two Variables. And now for a brief introduction on Section 2.8. What is a linear inequality in two variables? A linear inequality is a linear equality without the equality sign. Yay! Instead, we have, what do we have? Greater than or equal to, less than or equal to, greater than, and less than. All the signs of the rainbow. Which solution satisfies the following equation? 3x minus 2y is greater than or equal to 5. Could it be A, 1, negative 1, B, negative 2, negative 4, C, 2, 3, or D, negative 3, 5? Here's the solution. You need to substitute the numbers in. For instance, in A, it will become 3 into 1 minus 2 into negative 1 is something compared to 5. Eventually, you will work it out to form that 3 plus 2 is equal to 5. You need to do that with the rest of the problems as well. Take your time to check. When you're done, look up at the screen. As you can see, in only A was the equation with the substituted numbers equal to or greater than 5. Therefore, A is the correct answer. As you can see, for B, C, and D, the resulting answer was less than 5. It was 2, 0, and negative 19. None of these are greater than or equal to 5. Now, let's check on Kimberly.
Graphing Linear Inequalities by Kimberly Zhang. So the vocab for this section is that the graph of a linear inequality in two variables is a set of all points in a coordinate plane that represents solutions of the inequality. And so here I have an example of a graph of a linear equality for the inequality y is less than 2x plus 1. Now to the steps to graphing a linear inequality. First, you need to graph the boundary line for the inequality. The line could either be dashed or solid. Solid lines mean that the points on the line are solutions to the inequality, whereas dashed lines means that the points on the line are not solutions to the inequality. And so here I have two examples for you for both dashed and solid line. Now for step number 2, you need to test a point not on the boundary line to determine whether it is a solution of the inequality. I chose a point 3, 2, inputted it into y is greater than 2x plus 2, solved out the problem, and got 2 is greater than 8, which is false. And so, as a continuation to step number 2, if it is a solution, shade the half plane containing the point. If it is not a solution, shade the other half plane. And so 2 is greater than 8 is not a solution, so I shade the other half plane. And so here's the completed graph of my linear inequality y is greater than 2x plus 2. Thank you.
Okay, so the first problem is going to be y is less than or equal to negative 4. So first, we're going to draw the graph. And first comes the y-axis. And now that's done. So y is less than or equal to negative 4. So we're going to find negative 4, and we're going to draw a solid line through there. And then we're going to shade the region below negative 4. So then after that, we're going to check if everything is correct using the origin 0, 0. So the y, which is 0, of course, is more than negative 4, so it's not in the shaded region. And then the next equation is going to be x is greater than 5. So we're going to draw the graph again. Yeah. So then we're going to draw a dotted line on 5 because it's greater than, not greater or equal to. And then we're going to shade the region past 5. So then we're going to test that again with the origin. And because 0 is less than 5, it's not included in the shaded region. So there you have it.
Hey guys, it's Sarah, and I'm here to teach you how to graph linear equations in not one, but in two variables. As you can see here, y is greater than x is a very simple multivariable linear inequality. To graph this, you'd first have to graph y is equal to x, which is this line right here, passing through the origin of the graph. Everything above this is y is greater than x, everything below is y is less than x. So this shaded region right here satisfies y is greater than x inequality. But that's pretty much the simplest inequality you'll come across. If you come across something more complicated, something like this, y is greater than or equal to 2x plus 2, what you do is substitute the value of y for 0. So 0 is greater than or equal to 2x plus 2. Then you move 2 to this side. Minus 2 is greater than or equal to 2x. Divide both sides by 2. Minus 1 is greater than or equal to 2x. X is less than or equal to minus half. Then to find y, you'd substitute the value of x for 0. Y is greater than or equal to 0 plus 2. Y is greater than or equal to 2. So all the values of x that are less than or equal to negative half and greater than or equal to 2, if you plot them all on a line, you should get your boundary, and everything above that should satisfy the equation, and the boundary line should also satisfy the equation. That's how you graph linear inequalities with two variables. Thank you for watching, and I hope this makes your graphing problems easier. Bye!